The topic of this video is basic exponent operations. Normally we'll stick to only one example per video in this channel, but for the purpose of these, they're pretty short and sweet, so we can do multiple problems in a relatively short amount of time. Jumping in, our first example will be an exponential zero rule example, which simply states that any number raised to the zero power is equal to 1. And in this case, we have 3 raised to the zero power, which is equal to 1. The next property example would be 3 raised to the first power, which is equal to just 3. This is an example of the exponential identity rule, which simply states that any number raised to the first power is that number itself. The next example will be simplifying this expression, which is 10 raised to the third power times 4 raised to the negative second plus 7 raised to the negative second. The first step is to convert our negative exponents into fractional exponential form, which we can use using the negative exponent rule, which basically just states that any number raised to a negative exponent can be rewritten as 1 divided by that number to that exponent. The next step is to expand the exponents on the bottom so we have regular numbers in fractional form. This can be done using simply the definition of an exponent, which is just repeated multiplication. Next, we have to find a common denominator so we can add these fractions together, which in this case can be done just by adding or multiplying by 49 and 16 in fractional form. You can also find a least common denominator, which can simplify things quite a bit, but in the case where you're using the calculator or have one available, it's not really necessary. Now that we have a common denominator of 784, we can just add these two fractions together to get a fractional number that we can multiply by 1,000 to find our fractional answer. With that said, for this problem, we end up getting 65,000 over 784, which is about 82.9082, rounding. Our next example is 5 raised to the third power raised to the fourth power divided by 5 raised to the third power raised to the second power. In this example, we can first use the power to a power rule to simplify our exponents. As you can see, I can talk a lot faster than I can write. Once we've simplified our exponential powers, we can then use the quotient rule, which basically states that when dividing by two exponents of the same base, you can substitute division with subtraction of the exponents, which is the form bx over by is equal to bx minus y. And lastly, this gives us 5 raised to the 6th power, which is just 15,625. For this problem, the first step is making some initial simplifications, which I did by separating the 4/3 and the negative 4/5 into a more simplified 3 raised to the 4th power raised to the 1/3 power, and then 1 over 2 raised to the 4/5. This allows us to get rid of the negative exponent on the right side and then carry on with the problem. Next, we can evaluate the 3 raised to the 4th, which is 81. And then we can also pull out the 1/5 from the 4/5 exponent of the 2. And this allows us to simplify it even more in the next step by converting them into cubic roots and evaluating the 2 raised to the 4th power. From here, I'm going to evaluate 81 raised to the 1/3, which is equivalent to the cubed root of 81. And then in this next step, I'm also going to convert the 16 raised to the 1 over 5 into the 5th root of 16, which once again they're equivalent. And then once we have those actual numbers, the rest of the problem is basically just simple math. Here we end up with 8 times 4.32675 minus 15 times 1 divided by 1.7411. Then rewriting this, we can convert the 1 over 1.7411 into 8.6152, and then all of this together can be multiplied through and evaluated, which I didn't have written down beforehand, so I had to actually figure out. But you end up getting, for the first part of the expression, 34.56, rounding off the 6 point, or rounding your 0.32675 to just 0.32. And then for the second half, you end up getting about 129.228, which gives you a final answer for this particular problem of negative 94.668. So thank you for watching, and hopefully this was a bit helpful for anyone who didn't completely understand exponents to start with.